let's talk about this. So go ahead. I'm going to give you a minute to write. Okay, you've got 30 seconds, and I'm going to start. If you are done writing, I would get that function typed into y sub 1, making sure there's parentheses around the denominator. Yes, type that in. Put it under y1, but parentheses around the denominator. I'm trying to make this so you don't have to type it in a million times. All right, you ready? Do you have the function typed in? Type it into y1, putting parentheses around the x minus 2 in the denominator. All right, everybody got it in? Yeah, I'll get one in a minute. Okay, here's what we're going to do. We've done this limit thing in the table before. All right, so we're going to fill in the values into the table. Okay, so what you need to do is go out to your home screen. So exit to your home screen once you have this under y sub 1. Okay, and then I want you to push vars, yvars, and do y1. So remember, yvars, you have to go push the arrow over on the menu, right, to get the yvars. And then once you've got that, put a parentheses and type in this number, 1.5. And then hit enter and tell me what you get. -6 sounds good. If you didn't get -6, you probably did something wrong in your y1. Now, instead of going through all those motions again, hit second and your enter button. And it will pop up the y sub 1, 1.5, and just type over the top of that, 1.9. And tell me what you get. -30, good. Second, enter again. All right, I'm going to give you about 30 seconds. I want you to finish the table on your own. Don't do 2, because 2 is undefined. Bruce, you got it done? All right, what do we get for 1.999? -3,000. What about the 2.001? 3,000. What about the 2.01? 300. The 2.1. And the 2.5. 6. Okay, so now we're going to examine our two limits as we're approaching from the left and as we're approaching from the right. As I get closer and closer and closer to 2 from the left, what's happening? It's going down, right? It's getting closer and closer and closer to what number? Negative infinity is how we would say that. It's getting bigger, and the numbers, well, really getting smaller and smaller and smaller, right? Okay, as we're coming in from the right side and get closer and closer and closer to 2, what's happening? It's getting bigger, or how would we say that? It's going to infinity. All right? Remember, whenever we have a denominator and something's left there in the denominator, it is an indicator of asymptotes. All right, here we go. The limit as x approaches, and we're supposed to be looking at as x approaches, it says 1 from the left and from the right. So the 1 from the left, limit as x approaches 1 from the right of our function. You just could put f of x. All right, so we're supposed to be deciding whether it goes to infinity or negative infinity. Not a whole lot of work we're showing on these, right? We're looking at the graph and reading it. So as I'm coming in from the left side, what's happening with my graph? Going to negative infinity. All right. As we're coming in from the right side, what's the graph going to? Positive infinity. All right, let's try it again together. So the limit, this really isn't that hard today. Limit as x approaches from the left, limit as x approaches from the right of my function. All right, so as I'm getting closer and closer and closer from the left side, what's my graph going to? Positive infinity. I guess that's a way to remember it. Okay. I don't want to know what you say for negative infinity. All right. All right. As we get closer and closer and closer to 1 from the right, where's my graph approaching? Positive infinity. Okay. They're both going to infinity. Okay. All right. I'm going to give you another one. All right, on this next one, is this the same? No, different graphs. Okay, on this next one, I'm going to give you a minute and a half to sketch the graph and write the limits down to yourself without your neighbor's help, Kevin. No, the black line was it just didn't scan well. So that black line is not part of it. This one? No, it's just x minus 1. No squared. Make sure you've done your limits, not just sketched. Okay, you've got about 20 seconds to get your limits down there. All right, let's check and see how we did. So, Bruce, as I'm coming in from the left-hand side on C, what is it approaching? Positive or negative? Positive infinity. All right. Shh. You guys need to be listening, not talking over the top of me. All right, Seth, what are we approaching from the right? Negative infinity. Good. All right, on D, Martina, what are we approaching from the left? Negative infinity. Good. Jamie, what are we approaching from the right? Positive or negative? Negative. Good. All right. Hopefully you got them correct. Let's go ahead and move to the vertical asymptote definition. Okay? This one, write down. So this one you need to write down the definition. I'll give you a minute to do it. Here we go. Kevin, pay attention. All right. Shh. If f of x approaches infinity or negative infinity as x approaches c from the left or the right, then the line x equals c is a vertical asymptote of the graph of f. All right? So basically, it's whatever's left in the denominator, but if you're getting those asymptotes, or if you're getting the, approaching infinity from one direction or the other, you know that you've got an asymptote of some kind. Okay? All right, so go ahead and write that one down. We're supposed to find the vertical asymptotes, if any, of the graph of the function. And we're starting with f of x equals 1 over 2 times x plus 1. All right, here we go. So in order to find vertical asymptotes, we need to take this and set it equal to 0. Do I really need the 2? No, the 2 is just going to go away. So I really am going to set that x plus 1 equal to 0. What am I going to get? X equals negative 1 is my vertical asymptote. To get the vertical asymptotes, we set the denominator, what's left in the denominator, equal to 0. The 2 would divide out, right? So if I set that equal to 0, the 2 divides out, and I'm still left with x plus 1 equals 0. Okay? Because to find the vertical asymptotes, we set the denominator equal to 0, whatever's left. If it cancels, it's a whole. If it's left in the denominator, it's an asymptote. All right, here's the next one. Write it down. All right, there's a couple ways to do this one. Instinct tells you to do what with it? Factor it. Can I factor the numerator? No, it's a sum of squares. We can't factor a sum of squares. So the denominator, what does that factor into? X plus 1, x minus 1. So does anything cancel with the numerator? No, so both of those get set equal to 0 by zero product property, right? And then we've got x equals, what are my two asymptotes? Positive and negative 1. Could I have done this? Could I have just set the denominator the way it is equal to 0? And then wouldn't I have gotten square root of plus or minus 1, which is plus or minus 1? So same thing. It depends on how you see it. Both of them work. Okay? Just the denominator is what determines the asymptotes. All right. Last one for today. All right, shh, you need to listen. So I have to determine asymptotes on cotangent. Looking at the graph of cotangent, that there are definitely, right? So let's rewrite cotangent. What's another name for cotangent? 1 over tangent doesn't help me. Cosine x over sine x. All right, so I need to set this equal to 0 and solve. So sine x equals 0. All right, so I'm going to go back to my good old unit circle.
Mercedes Ramirez, please come to the front office. Mercedes Ramirez to the front office.
Okay, so shh, listen. That's the last one. So where are the two values where sine x is equal to 0? Pi, 2 pi, or we could call that 0, right? So really, another fancy way to write it is for n at n pi, right? If we were going to go at any revolution around, so anytime we have something followed by, or a constant number followed by pi, we would have